Hello guys, let's start off with unit number 1, mechanics and materials. So we will be starting off with mechanics first. Today we are going to be primarily focusing on motion. In the first few lectures we will be discussing what is motion, what is the basics of that chapter. Then we'll be covering the equations of uniformly accelerated motion in a lot of detail. After that, what I do is we'll just do the experiment to determine acceleration, whatever part is related to the motion, and then we'll be covering the graphs of displacement time and velocity time with that acceleration time as well. We'll be covering the quantities what are involved in those areas, and with once we're done with that, I would be moving on to the concept of horizontal projectile motion. Well, once we are done with all those concepts, I will be moving on to vectors. Most probably before projectile, I'll be doing vectors just because you understand what vectors are so that you can apply those concepts when it comes to the projectile motion. So this is going to be the series of lectures. This series of lectures will help you a lot and eventually would get you to your desired grade. Starting off with what is a kinematics or what is motion, because we have to discuss it. It's a very vast part of our first mechanics chapter. When it comes to kinematics, we all know that generally kinematics is a study of motion. And in mechanics, whenever we are talking about motion, we will be starting off with first term, that's distance. Guys, if we have got 2 points, and if I were to reach any point with any certain distance, that is in general length between 2 points. So length between 2 points is known as distance, and distance is a scalar quantity. Scalar quantity. Any quantity that only has magnitude and a unit. Magnitude means size or a number. For example, I say this brown path is 50 meters. So this brown path coming from right or going from left is always going to be 50 meters. That 50 is the magnitude and that meters is the unit. This is going to be very basic understanding of what distance is. It is measured in meters. It's a scalar quantity and that is measured in meters. We are very well aware of distances because we are from IGCSE background, so we know what distance is. Very well. Moving on, what is displacement? Kids, displacement is the length traveled in a straight line in a specified direction. Length in a straight line. Displacement is going to be in a straight line. So if I'm going from A to B, the shortest possible distance from A to B is going to be known as the displacement. Length in a straight line and it is a vector quantity. That means quantities that have magnitude, unit and as well as direction involved. So vector quantity would have magnitude, unit and direction. So vector quantities, we are very well aware of what are vector quantities. They have magnitude, they have unit and they have direction involved. Usually in your IGCSEs, we used to take direction as positive when we are going to the right hand side, and we used to take direction as negative when we are going to the left hand side. But in IAS, it's not specified. They can give you the direction of like downward as to be positive or going to the left as positive. So if you're taking left direction as positive, you need to realize that the right direction would be negative in that case scenarios. Moving on, we have got speed. Speed, we all know, is the rate of change of distance. It is basically distance traveled per unit time. So speed is the rate of change of distance traveled per unit time. Speed is given as v and then distance over time. Usually in AS we write distance as s, but it's okay. Speed is a scalar quantity. If someone is traveling at 50 meters per second, there's no direction involved. So if something is moving with 50 meters per second, whether he's moving to the right, whether he's moving to the left, up, down, doesn't make any difference. You do not have direction involved when it comes to speed, since it's a scalar quantity. Whereas we have got velocity. Velocity is rate of change of displacement. Velocity is displacement divided by time. If we are moving to the right, we take velocity as positive, and when we are moving to the left, we usually take velocity as negative. So velocity is displacement divided by time, or displacement covered per unit time, or rate of change of displacement. So velocity basically is negative in the negative direction, and it is positive in the positive direction. So this is some basic understanding of what velocity is, some basic understanding of what speed is, and that is a general background for the chapter. Moving on, if an object is moving in a circular motion, now you need to realize this concept. If something is moving in a circular motion, so if they ask you what is going to be the average velocity of an object, so in a circular motion, average velocity is always zero. This is asked a lot of time in your MCQs. So average velocity in a circular motion is equals to zero, because there is no net displacement. If something is moving and coming back to the same point, it would have no velocity because there would be no displacement. So in a complete circular motion, if something is moving in circles, even the displacement is going to be zero, because object is not covering any displacement. Rather, object is just moving in circles and coming back to the same point again and again. Now, there's one more question that is asked a lot of time in the examination. There was this question you started and he said that there's a track, and he said that the track is totally of 200 meters, and he said the track is of 200 meters, and the question was that he covered 100 meters, and they were asking about the displacement of the object. So if let's suppose I start here and I, let's say, cover over here, I like end over here, and I need to find displacement. So it is not going to be the curved path. Rather, if I need displacement on a circular track and half of that is traveled, this is going to be the displacement. So this distance that I just drew with a dotted line, that is what I need. So if let's suppose they have given us the circumference to be 200, so I would be doing is 200 is equals to 2 pi r, where 2 pi r actually is the formula for the circumference of a circle. So I would be doing 200 is equals to 2 pi r. Once I have done that, then I would be taking out my calculator, and then with the help of the calculator, I'm going to be calculating the radius. So this is a lot of time I've seen this in the MCQs, so be very prepared. Okay, so I've got like radius that's around 31.8, which is going to be equal to 32. So if I've got the radius, then I can safely say that this is going to be 32. So twice of that would be 34. So if I'm starting at this point and I'm covering like half of the track, and they ask you about the displacement, that displacement is actually going to be the diameter of the path, which is going to be around 64 meters. So I hope you get my point, that when it comes to displacement, you need a straight line distance, that is shortest possible distance, and it's always going to be in a straight line. That is some very basic understanding. Moving on. The next thing that we discussed in our IGCSEs, or that we have to discuss in our A-levels a lot, is going to be acceleration. Kids, acceleration is rate of change of velocity, and acceleration was final velocity minus initial velocity over time. This is one formula for acceleration, and there was this other one in which that was v square minus u square equals 2as. For all those who gave your IGCSEs from Pearson Edexcel International GCSE, this formula was part of your syllabus. And for all those who did not give your O levels or IGCSEs from Pearson, rather they chose Cambridge or some other boards, Might be possible this formula is not in your syllabus because in Cambridge IGCSE or Cambridge O levels, this formula is not in your syllabus. Only this formula is what we used. But it's okay. There's nothing to be worried about. I'll be discussing everything. Okay. So acceleration is rate of change of velocity, and formula of acceleration was final velocity minus initial velocity over time. And this formula that we just discussed is found from the gradient. This is just the gradient, that y2 minus y1, because velocity time graph, if you get the gradient, you get the acceleration. So this formula is derived from the gradient of the graph. So it is final velocity minus initial velocity over time. You get change in velocity divided by time. You get the time taken to change velocity. In general, if I would have to say what acceleration is, it is how much time is needed in order to change the velocity. So if I have to reach a certain velocity from a certain velocity, so if let's say I've got a car starting at 10 meters per second, reaching 100 meters per second in 3 seconds. So what is the rate? What is the per second rate of increasing my speed? So I would say first I would get the increase in speed. That would be 90. And then I would divide it by 3. So I would get 30 meter per second squared. This means every second I've been changing my speed by 30 meters per second. This 30 is the rate at which I'm changing my speed. So rate, every second what speed is being changed in the body that is moving, that is known as acceleration in very basic terms. Moving on. This formula of acceleration, or we have some other formulas as well that we'll be discussing in a while. But before that, we'll be doing what are the types of accelerations. Kids, in general, we say object is said to be accelerating when it is doing two things. First, it is actually changing its velocity value, more to high or high to low, doesn't matter, but that's said to be accelerating. And the second one is change in direction. If an object is changing its velocity's magnitude, there are two types of acceleration. First one is uniform acceleration. This uniform acceleration is a very, very, very important part of our syllabus. Is uniformly accelerated motion is asked in a lot of detail when it comes to IAS. So there are basically, when we're talking about uniform acceleration, there are certain concepts that you need to remember. If there's a car that is traveling at 0 meters per second, and let's say it gains speed to 10 meters per second, let's say again speed to 20 and then to 30. So each second, the object is changing its velocity's value by 10 meter per second. That means every second, each and every second, what I'm doing and I'm learning it, every second, the velocity is changing by 10 meters per second. That shows that each second the acceleration is uniform. The change in velocity is same every second. This actually means uniform acceleration, in which rate of change of velocity is uniform. Rate at which velocity is changing every second is uniform, and this is called a uniformly accelerated motion. But in case if the acceleration is non-uniform, there are again two types. First is increasing acceleration. That means if initially the speed increase was 10 and then the next second the speed increased by 20 and then the next second the increase speed or velocity increased by 50, this shows that initially acceleration was low, and as the object started moving, the acceleration also increased. So this is increasing acceleration that actually shows us that the object is getting faster. That's okay. Object was getting faster in this case scenario as well. Both of those cases, the object is getting faster. But in this case, object was getting faster with the same rate every second. And in this second one, in increasing acceleration case scenario, the object is getting faster and the rate at which it is getting faster is also increasing. That's increasing acceleration. Third, we have got decreasing acceleration, in which again object is getting faster, but its rate of change of velocity is decreasing. That means each second, like previous second, if the speed increase was 10, in the next second it was 8, in the next second it was 6. So although the object is still getting faster, the object is still gaining speed, but the rate at which it is gaining speed, that rate is decreasing, declining. That is known as decreasing acceleration. This thing has nothing to do with deceleration. A lot of students actually confuse this. Deceleration, my kids, is negative acceleration. It basically suggests that the magnitude of velocity is going to go down. If the car would be slowing down, or if the object is going to be slowing down, that suggests that it's decelerating. So if, let's say, the car was moving at 100 and then it reduces down to 70, 40, so something like that. This is known as deceleration, in which each second the speed or velocity is going to decrease at the same rate. This actually is deceleration. Whereas in decreasing acceleration, the car is getting faster, but the rate at which it is getting faster, that rate is reducing. Getting difference. So make sure that you don't confuse these two valid things. Deceleration is something very different compared to decreasing acceleration. So this is all the change in velocity or change in magnitude part of the acceleration. There's also one other kind of acceleration that we used to discuss in our previous levels, is that when an object is moving in circular motion, we also say that object is said to be accelerating. It is because of change in direction. In very basic terms, if I were to say if something is moving up, its velocity is, for example, plus 10. If it's moving to the left, its velocity is negative 10. Moving downwards, its velocity is negative 10. If it's moving to the right, the velocity is plus 10. So you will realize that I have taken upward direction as positive. So the direction of motion is changing, although the speed is constant, speed is uniform. But since the object is changing direction and velocity is a vector quantity that involve direction, so if something is moving in circular motions, or car is taking a turn, or something is moving in a turn or something, we can say it's accelerating because of the direction change that causes the velocity to be changed, and therefore we can say that object is accelerating. So to conclude that, we discussed what is distance, displacement, velocity, speed. We discussed two types of acceleration in general. One is uniform acceleration and the other one's non-uniform acceleration. Changing in direction is not very important, but okay. But our primarily focus is going to be uniform acceleration, in which every second the rate of change of velocity, kids, are going to be staying constant. Every second, each second, the rate at which the velocity is changing is going to stay the same. So this is going to be the uniform acceleration. Moving on. Before concluding lecture number 1, the last part for this lecture is going to be equations of uniformly accelerated motion. Equations of uniformly accelerated motion. In our syllabus, we have got four equations of uniformly accelerated motion. Number 1, V is equals to U plus AT. Number 2, V square minus U square equals 2AS. Number 3, S is equals to UT plus half AT squared. Number 4, S is equals to V plus U over 2 times T. These are the 4 equations of motion that can only be used in uniform acceleration. Uniform acceleration, that's it. We can only use them in uniform acceleration. Why? Because they are equations of uniformly accelerated motion. V is final velocity. U is initial velocity. S is displacement. T is time. and A is acceleration. Kids, these are five things that we have involved. So the question is why four? Why not one? But if there are like different concepts, if you have no time, you can use this one. If you have no final velocity, you can use this one. So it depends upon question to question, situation to situation. There are a few situations you can use both of them, or three of them, or four of them even. But make sure that you understand the concept. These equations are also known as SUVAT equations. So whatever name suits you, SUVAT is a displacement, initial, final, acceleration time. So they are also called SUVAT equations, but I recommend to call them uniformly accelerated motion equations. That's it for today. That is lecture number 1. I hope you enjoyed the lecture. Next lecture is very interesting. That was the understanding of the chapter. And in the next lecture, we'll be working in detail for the uniformly accelerated motion equations and how they can be applied in a single dimension. We'll be doing horizontal motion, we'll be doing vertical motion, and we'll be doing more than that. Take care, guys. See you in the next lecture. Thank you. Hello guys, this is Sir Mahad Amer and welcome to another lecture. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is a direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.